Students, I am very much happy to take this small class today. This is about ONEWAY ANOVA. ONEWAY means we are doing by column wise or row wise. We are going to analyze the variance. Therefore, the title ONEWAY ANOVA, row wise or column wise only. So let me take, as we already know that there are important steps here. The first step we know already is about, first step we know it is what? Null hypothesis. That's what the first step. Correct. Now it is not good. Null hypothesis. Null hypothesis. The second step is alternative hypothesis. Alternative hypothesis in short form I'm writing here. And third step is about calculation of F statistics. The fourth step is about table value, to find table value of we know that ft. Then we know about table value, and fifth step is about comparison of what? Comparison of FC and FT. Our last step, you must note that the last step is what we have studied already. The last step is about conclusion. So these are some of the steps in any test of hypothesis. That is shoots here also. Okay, that shoots here also. Now let me take one problem. Now I will take one problem here. Okay, now let us take the problem here. I think it's going very small. Now I have to set again the slides. Now I'm going to take the problem. What is the problem about? Okay, now let us take the problem. This is the problem. Okay, now look at that. Look at that. So how many problems here? I mean, how many technicians are here? Technician 1, technician 2, 3, 4. So the output for these 4 technicians for 5 days are given here. These are the technicians. These are the 5 days outputs. Okay, take for example. Now I will maximize the screen so that you understand more. So first day his output is 6. For first technician, the 5th day input is 11. For the third technician, the 7th is the output for the third day, and technician 4, 10th is the output for the 4th day. So like that the problem is given to us. Okay, now what is the question here? What we have to do? Now we have to check whether the homogeneous behavior exists between the technicians. I mean, all the technicians, these 4 technicians, acted equally. Their performance is equal or not. That's what the question here. Okay, so column wise only we are going to discuss today. That is the performance of the 4 technicians are homogeneous or not. That's what the question about. Right, now look at that. We know already there are certain steps. There I told you some 6 steps are there, and through the 6 steps we have to solve that. The first step is null hypothesis. What we assume here, these 4 technicians, 1 2 3 4 technicians have homogeneous character. They have acted equally. Like that we are assuming, and that is what step number 1. Okay, step number 1. Now the step number 2 is alternative hypothesis. Alternative hypothesis is exactly opposite to null hypothesis. That is, there is significant difference between the behavior of the 4 technicians. That's what the alternative hypothesis. Okay, and then the third step is that we have to calculate FC, the statistical methods for Fisher's test. Here we are using Fisher's test. Calculated value we have to find out, and Fisher test tabular value we have to find out. Okay, so we have to start that. So the third step is calculation of test statistic F. That's what we have to understand. Now look at that. This table, if you look at this very closely, you will see that some 2 digits elements are here. 2 digits, am I correct? So now our process is based on squaring and adding. Everything will go on the process of solving the situation. So what we have to do here is that we have to reduce the 2 digits into a single digits, so that squaring and adding everything is equal, very easy. So that's the first step we are doing here. Okay, so what I do there, the center number here is 10. We can take 10. Okay, so subtract here. What is that they have done here? We have to take the number 10. Okay, take the number 10 and subtract from each and every element here. 6 minus 10, your answer is what? Minus 4. 14 minus 10, you get 4. Like that, all the elements we are subtracting. 12 minus 10 is equal to 2. Similarly here, 11 minus 10 equals 1. Like this we do. We are reducing all the 2 digits number into a single digit number, and we get this particular table here. Look at that. Now look at that. So this is what the table we are having here. Now this is the table is given to us, and we have reduced that table. This is the table, the problem table given to us, and we are reducing it by subtracting 10 from each element. Look at that. This is the problem table given to us. Okay, this is what the problem table given to us, and we are subtracting 10, and we will get this particular table. Okay, look at that. This is the particular table you will get. The blue bordered box. That's what we'll get. Okay, now this is what we have. Now the next step is that we have to add, we have to we have to add these elements and write here -4 plus 4 0 0 plus 0 0 0 minus 2 minus 2 plus 1 minus 1, like that. Add this number right here, add this number right here, add this number right here, add this number right here. This is the first step we have to do here. Okay, so what I mean is that we are taking this particular table and then we are adding, column wise adding. We are writing here, column wise adding, writing here, column wise adding, writing here, column wise adding right here, column wise adding right here. That is for the first step, the calculation. Now this side, that is this side, what we have to do, let me minimize the screen so that you understand well. Now look at that. You are squaring these elements right in here. -4 square 16, 4 square 16, 0 square 0, 2 square 4, 1 square 1. Similarly from here to there. Okay, similarly from here to here. 4 square 16, 4 square 16. Then here -1 square 1, then 2 square 4, 0 square 0, 4 square 16, like that. We have to square the numbers. Similarly here, square this, you will get this column. Similarly square all these elements right here. Okay, here you have to write. Okay, we have to write here. This is what the step you have to understand. So this column all square, you will get this same thing. You are adding right in here, you are adding all these things right in here, adding all these things right in here, and adding all these things right in here. Now what is this? Sum of x1 square. What is this? Sum of x2 square. What is this? Sum of x3 square. What is this? Sum of x4 square. Okay, now we need this also. Step number 1 is given, n equals 20. What is this 20? Look at that. The 20 is nothing but the number of elements given to us. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So 20 elements are given to us. So that's what n equals 20. Okay, so this is the next step that you have to understand. Okay, so next step is, from this table we have to calculate the components of ANOVA, that is TSS, total square sum, a total sum of squares, total sum of squares. Okay, total sum of squares. Look at that. So these are squares, there's some squares, there's some squares, there's some squares, there's some. So that's what we have here. So sum of x1 square is 37. That 37 we are writing here. The sum of x2 square, this is what, that 37 we are writing here. And 39, sum of x3 square, 39. And last one, sum of x4 square is this sum of x4 square. So apart from this, we have to write here t square by capital N. That should come here, t square by capital N. Right. So if you add all of them, what answer we are getting is 114.55. So we have got TSS we have got. Similarly, SSC, that is sum of square column wise, sum of square column wise, sum of square column wise, that's what SSC. For this, the formula is summation x1 whole square divided by n1. N1 means number of elements here. Now look at that, how many elements are here? 1, 2, 3, 4, 5. Am I correct? So that 5 we have to write here. So the summation of x1 square, this is x1 square, summation of x2 square, summation of x1, summation of x2, summation of x3, summation of x4. So what we have to do, here we have to write this minus 1 the whole square divided by 5, because there are 5, 1, 2, 3, 4, 5 elements are there. Similarly, we have to do everything. So we have here 9, so 9 here, 9 square divided by 5 elements are there, and then here 5 is here, so 5 square divided by 5, and minus 0 is also there. We get that 0 is here, so 0 square by 5 is 0, minus t square by n. T square by n is what? 114.55. If you calculate that, you will get this one. Okay, so this is the way we can calculate SSC. We can calculate SSC. We can calculate. Okay, now SSC means what? TSS. TSS already we have here. I mean, TSS already we have here. SS, the value is 114.55. SSC value is 12.95. So now SSE we can calculate by using the formula TSS minus SSC. TSS is this 114.55 minus 12.9, that is here 12.9. the answer is 101.6. so this way we can calculate all the values here. TSS we can calculate, and then we can get SSC we can get, and SSE also we can get, because these are the requirements to fill up the ANOVA table. Because in the next slide I am going to show the ANOVA table. Okay, so in that table all these values are needed for us. So keep in your mind that we'll go for the next table. Okay, now this is what we say ANOVA table. Okay, ANOVA table, this ANOVA table, and this one is sum of what can I say, sources, they will say sum of sources, and this is degrees of freedom. This one is mean square, this is variance ratio, and last one is table value of f we have to find out. So this is what very important thing we have to understand. Now SSC, so how much SSC? You go back and see that SSC value is 101.6. that's what we are writing here. 102 point here SSC is what the answer, 12.95. so 12.95, that is what SSC. now C minus 1, C means number of columns. Here how many columns are here? You look at that, columns 1, 2, 3, 4. actually from the given problem we have to see how many columns are here. Now look at that, how many columns? 1, 2, 3, 4 columns are there. That is what the n here. Okay, in this table, ANOVA table we have here. So here C is 4, 4 minus 1 equals 3. Now MSC, mean square column wise, mean square column wise, that is what we say MSC. So Now this is ANOVA table. Already I have told you sum of sources we say, and degrees of freedom, mean square, variance table F. Okay, here SSC means sum of squares column wise. What's the value? Already we have got here SSC value here is 12.95. that's what we are writing here, 12.95. the degrees of freedom for SSC is C minus 1, where C is number of columns. Now look at the problems given to us. How many columns are there? Look at that. 1, 2, 3, 4. So 4 columns are there. 1, 2, 3, 4 columns. So that's what we have to write here. Okay. Now here we have to write that. So here C is 4. 4 minus 1 equals 3. 4 minus 1 equals 3 here. Now what is MSC? Mean square column wise. Mean square column wise. That's what MSC. So the formula is the sum of square column wise divided by C minus 1. Sum of squares column wise divided by C minus 1. So sum of squares column wise is 12.95, and here C minus 1 is 3. So if you divide 12.95 by 3, we will get 4.32. We will get 4.32. Now MSC we have found out. MSC mean square column wise. Now next variance ratio. Then next what we have to calculate is this we have to calculate MSE. Okay, so MSE is SSE divided by N minus C. Now what is SSC? We have already calculated. SSE equals 101.6. 101.6. that's what SSE. So that's what we have here, 101.6. N minus C. We know what is N here, right? So N equals 20, because 20 numbers are here, observations. So we get 20 minus number of columns 4, 16 we have 16 here. So what is the formula? MSE means squared error. Mean square error, that's what we say. That equals SSE divided by N minus C. SSE is 106.6 and divided by 16. Divide by 16. Okay, so if you divide by 16, you will get 6.35 here. The answer here 6.35. 6.35 here. 6.35. That's answer you'll get. 6.35. That's what the solution here. Now look at that. We have got MSE, we have got MSE. MSE value is 4.32, right? Whereas MSE value 6.35. Which number is greater? 6.35 or 4.32? And this number is greater. Okay, so when we calculate FC, calculated value of F, the greatest among these two we have to write in the numerator. Greatest among these two, MSE and MSE, we have to write in the numerator, and small number in the denominator. So the 6.35 we are writing here, and 4.32 we are writing down, and that gives you 1.47. And this is called the calculated value of F. The calculated value of F is nothing but MSE divided by MSC, which that is we have to compare this value, which number is greater, that you write in the numerator, small number in the denominator. You divide them, you will get the value 1.47, and this is called the calculated value of F. So we have got the calculated value of f as 1.47. 1.47 is the calculated value. That's what we have get. Now we have to find the table value. Am I correct? So next we have to get the table value. Am I correct? So to get the table value, I have to go to the next slides. So this slide is a very important slide where we can get the tabular value of this. Okay, so here we must understand the tabular value, the step number this is step number 4, I think. Am I correct? So actually this is step number 4. Step number 4. Now let's take the white color now to find table value. Am I correct? So that's what you have to understand. Step number 4, to find the table value here. Okay, so to find the table value we need this one. Let me go back to here. Now table value, what level you should know here. So we are taking 1% level here because level is not given in the problem. Just see the question given to us. So just we have to, is there any homogeneous behavior, at which level? The level is not given here. So we take that at 1% level of significance. Okay, then this FC we have written calculated value of f. From that, what is the numerator? Numerator is MSE. So MSE is here. What is the degrees of freedom? 16. That 16 we have to write first. Numerator, degrees of freedom, we have to write first. Next one is the denominator. What is the degree of MSC? 3. That we have to write here. I repeat again, to find the tabular value we need this. Okay, we need this. The first place, second place, how to fill up that? The numerator you are seeing MSE. For MSE, what is the degrees of freedom? 16. That's 16 we have to write here. For this place, see the denominator MSC. Am I correct? For MSC, this is MSC. What's the degrees of freedom? 3. That we have to write here. Okay, so this is very important thing. So now we are going for the table. When you are seeing the table in the F table, the F table look like this. Okay, so what we have to do is that actually to find the table value of what? Of F for degrees of freedom, for degrees of freedom, that is F inside the bracket 16 comma 3. So this is a way we have to calculate the degrees of freedom. Okay, so degrees of freedom we have to get like this. Now in the table, that is F table will be given to us. So this is what F table. So in for 0.01 for 0.01 level of significance is not given here. We will take alpha equals or level of significance, level of significance you take as 0.01. So level of significance I am taking as 0.01, and level of significance I am writing as 0.01. Now again some problems on that. Yes, now look at the table here, screen here. The level of significance 0.01, and the value of F for degrees of freedom 16 and 3 is calculated this way. So this is the F table, and this is for 0.01 level, and this direction, horizontal direction, shows numerator value. Here the first number is numerator value, and the denominator value will be this one. Okay, so the degrees of freedom we have to see 16 in the numerator direction, so we have here 16, and in the second one, degrees of freedom, we have to see in the denominator side 1, 2, 3. So intersection of this and this gives you 26.9. So this is the way we can calculate the tabular value of F. Okay, so for 0.01 there would be a table. It look like this, F 0.01, and this side numerator degrees of freedom, and in this direction you will have denominator degrees of freedom. Okay, so in our problem here it is 16 in the numerator, so in this direction you are taking 16, and the denominator you have 3, so denominator you have 3, so intersecting point is 26.9. this is what the tabular value. So we have found out the tabular value as 26.9. Okay, now let me let me go to the step number 5, that is comparison step. Am I correct? Now look at the problem here. You will see that therefore the table value just found was 26.9, and already we have the calculated value as 1.47. you go back and see the calculated value there. Calculated value is here. We have calculated MSE by MSE, that is calculated value 1.47, and table value is 26.9, and we have to compare them. That is step number 5. Am I right? So step number 5 is comparison of FC and FT. FC already we have calculated as 1.47, and FT equals 26.9. just we found out from the table as we did like this, 26.9. and then fifth step, take the decision. Calculated value is less than table value, therefore H0 is accepted. When H0 is accepted? When the calculated value is less than the tabular value. Okay, here the calculated value FC is less than the tabular value of FT. That's what we see here. Am I correct? Now the calculated 1.47, and therefore that is less than tabular value of F. Therefore the fifth steps gives some idea that H0 is accepted because calculated value is less than tabular value. Now from that we can get the conclusion as follows. Now what is the conclusion then? There is no significant difference between the performance by 4 technicians. That's the one-way ANOVA. So now what we understand is that H0 is accepted. So H0 is accepted. Okay, that's what we are seeing here. H0 is accepted. H0 is accepted. So what is the meaning then? H0 is accepted. We assume at the beginning that we Now look at that. So this is what the first step. We have assumed that H0 is no significance between the 4 technicians. I mean, in this particular problem, 4 persons or technicians are acting equally. That's what we understand. So null hypothesis accepted, and alternative hypothesis rejected. There is significance difference is rejected, and there is no significance is accepted. Therefore, what is the answer to our problem here? Our answer to this problem is that is there any homogeneous behavior between technicians? And our answer is we have to understand that our answer to this question is there is no DrJ, there is no significance. There is no significance difference. There is no significance difference between the technicians. The technicians in performing the job. Okay, between the technicians in performing the job. In performing the job. So that's a way we have to. There is no significant difference between the performance. Okay, so that's what we have got. We got the answer for this problem. So this is a way we can do one-way ANOVA. Okay, so let us have a feedback on this problem, and you will see that there is no significance difference between the there is no significance difference between the technician is performing the job. That's what the answer. So let us have a feedback now. Okay, now now this is a problem given to us. One-way ANOVA we are doing. One-way ANOVA means column wise only we are taking into account here. 4 technicians, we have to check 4 technicians and their output in 5 days are given. Our aim is that whether 4 technicians are equally likely doing their job, performing equally. That's what our aim. That's what we are checking here. The first step is null hypothesis. There is no significance difference between the technicians. And second step is exactly opposite to that. That is alternative hypothesis. There is a significance difference. Then we are calculating f of c by different methods, not different methods, this tabular method, where this table coming from the previous given table by subtracting 10 from each elements, we are getting this one. Then we have to square them. We will get this one. We are adding all of them. We are adding all of them because these are needed to calculate this. So we are finding out TSS, and its value is 114.55. SSC also we are finding out. The value is what? 12.96. We are finding SSE, and that is 106. The next step is what? ANOVA table we have to do here. The ANOVA table gives a sum of squares. That is what SSC that you are filling up here. C minus 1, column minus 1, 3. The MSC means SSC by C minus 1. We are getting one answer. And then we have to find out MSE also. MSE means SSC divided by N minus C SSC. Already we have here 101.6 divided by N minus C. N means number of observations given to us. The total. So by using the ANOVA we can get the calculated value of f as 1.47. now it is tabular value, and already we know that the tabular value goes like this, and here we see that the degrees of freedom 16 and 3. The tabular value, this is the numerator and this is the denominator. Numerator 16 comes 16 and the numerator is 3. So intersection of these two will give us the tabular value. Now step number 4, we have got the tabular value as 26.9, and step number 5, comparison of FC FT gives us FC is 1.47, FT to 26.9. so calculated value is less than tabular value. As usual, we are accepting the null hypothesis. H0 is accepted. So on the basis of that we can get the conclusion as there is no significance difference between the performance of 4 technicians, and thus we got the answer for our problem. Okay, so this is the way we can do one-way ANOVA. So the answer is there is no significance difference between the 4 technicians in performing the job. So okay students, I am really happy that to see all of you here, and you've been very silent so far in listening to my my voice, and also very happy that you have been listening to this video very seriously. So congratulations, and I will come with another video in another day for 2-way analysis and 3-way analysis, and so many analysis out there. We will discuss about that. Thank you very much indeed. Thank you.